because he filled his. Okay. So, we need to remind ourselves of some topics from pre-calc. Right?
Pre-calc is coming back. Seriously? Oh,
Pre-calc.
Is the triangle of pre-calc?
Oh.
3 space.
I don't like that.
The x-axis is shooting out at us, the y-axis shooting to the side, and the z-axis up to the sky. Okay? We have 8 octants. Okay? They're counted just like the quadrants would be. But we start up here where all 3 are positive. That's octant 1, and we go back to 2, 3, up to 4. And then underneath of octant 1 is octant 5. And then we count around 6, 7, 8. So it kind of makes 2 horseshoes. Okay? We have 3 planes. We have the XY plane, which would be like the floor. Okay? We have the ZY plane, which would be like this wall that this board is on. And we have the XZ plane, which would be like this wall that side. Okay? So if those 3 were the 3 planes, we would be sitting in the first octant. And if we fell through the floor, we would be in the fifth. Miss Fanchulo's room would be the second octant. Okay. The distance formula in 3 dimensions.
You just added a z.
I just add a z?
You added z minus z squared.
Okay. I knew what you meant. I just had to. Okay? The distance formula in 3 dimensions is essentially just adding in that 3rd dimension. Do you buy it? Do you trust it? Should we prove it?
No, we shouldn't prove it.
You guys don't care at all.
I trust.
Sure,
If
let's
you've proven
prove
a
it this
2-dimensional,
one, it'll be fun.
if you can prove a 2-dimensional distance formula, I'm pretty sure proving a 3-dimensional is just the same, except you add another one.
I believe you on that question.
Okay, if this is the distance, okay, I can come up with a coordinate that lives in the same plane as the x and y coordinate here, and that is directly underneath the z, like it would have a different z value but the same xy. So this coordinate differs from this coordinate in its
Z value.
x and y, and it differs from this coordinate only by its z. So we can calculate, since these 2 live in the same plane, we can calculate the distance between these 2 like this, because the z coordinate didn't change. And then this distance here would be the absolute value of the difference in the z's. Well, now we have the Pythagorean theorem that would result in this up here.
Pythagoras.
Yeah. Okay. To go along with this talk of 3-dimensional distance formula, what do we call a 3-dimensional circle?
Sphere. 4 pi.
Is that going to be on the AP test?
Is that really?
I was looking at that.
I know, I wrote the SH and then I was like, wait a minute. So, as a reminder, in case you didn't hear me when we were talking about this before spring break, this is a bonus chapter.
Ooh.
You made me think of this. None of this will be on the AP test. But this is where you would start out when you start Calc 3. How many of you will go straight into Calc 3 next year? Okay, so you're adjusting to college life. things are a little bit different. At least we have some familiar math to fall back on. Okay. So the equation of a sphere. That looks familiar, right?
That's a circle. So we just squared the distance formula.
And then
We do the sphere.
it's supposed to be
That's weird.
okay. Where R is the radius and x naught, y naught, z naught is the center.
Is it possible to have the radius be a non-constant if you have functions in terms of x, y, and z?
So like an ellipse.
Yeah, like if you wanted an
So
ellipse.
if you want to look at three-dimensional conics, I will show you. Do I have this written? Do I show my?
I was just wondering.
They're in our book.
You mean-
I just can't remember which section. Let me look at the section before. I used to have you guys graph them, but it's not worth our time.
Ooh. I want to graph an oddball function.
Surface dimensions. So on page 796, it's actually 11.6. It's the section that we skipped. But in 11.6, there are all of the three-dimensional conics. So ellipsoids, hyperboloids,
Oh my.
elliptic
Thank you
columns,
for it.
elliptic paraboloids, hyperbolic paraboloids. Okay. I know, right? They're cool though. Okay, one more thing. How do we calculate midpoint?
X plus x plus x.
X plus x plus x over 2? What'd you say?
XXX Tentacion.
That's what you said.
How about just x plus x over 2? And y plus y over 2. And since we're in a third dimension, z plus z over 2. Okay? Are you okay that I'm not putting the subscripts on there?
No.
You're not okay?
So what does the little zero do? You use it at the center now.
It just means initial.
I'm just trying to differentiate between the x, y, and z that stay as x, y, and z, and then the x naught, y naught, z naught, those would actually be a number. Okay? If we want to find the midpoint, same like we would in 2 dimensions, average the x's, average the y's, but now average the z's. Okay? Okay.
Oh my god.
So I have a sphere that has diameter ends at 521 and 1, -4, 5. I want to know the equation of the sphere with that diameter, and it's passing through the center. That should be, it's kind of redundant because the diameter should pass through the center. Okay.
The diameter doesn't always pass through the center.
It always does. Okay, so what should we find first? The distance
Or we could just do the
between these
midpoint.
two?
We could just
And
do
what's
the-
that's going to find it? What is that going to find us? Okay, So we can find the distance between the 2 points. Joe, I know you have a different idea. Just hang on to it, okay?
We're gonna use both of them.
So we have 16 plus 36 plus 16. What? 68? Is that divisible by 4?
Okay, 64.
Thanks. Yeah.
I mean, you could do 4 and
So it is
17.
divisible by 4.
Yeah.
It is.
You had
Wait.
me all confused.
Why is the first one 5 minus 1? Shouldn't it be 5 plus 1? Because it's 5 and a positive 1.
Yeah, so we subtract them.
I thought it was x plus x.
That's why.
Is that what I wrote down?
No.
Oh,
No.
that's exactly what you
For distance, you I
wrote.
was
Okay.
Yeah. Okay. Whew. You had me panicking, Joe. Okay. So 2 radical 17 would be our diameter. So our radius is radical 17. What else do we need for a sphere? We need a center, correct? And how are we going to find the center? It tells us.
Yeah, but we need to find the mid.
But do
Is
we know
the
it?
diameter? What? Is that what you guys were talking about?
Yeah.
Oh, the diameter. For some reason, I was thinking that was the origin. I thought it was saying it passes through the origin. I was like, that's kind of redundant. That makes more sense.
So our center would be at 3, -1, 3.
Yep.
So our equation would be x minus 3 squared plus y minus -1 squared plus z minus 3 squared equals radical 17 squared.
Should just
So I'm just going to write 17. So that's okay. Okay. Now we found the diameter first. That led us to the radius, which then we found the center using the midpoint. If we would have found the center first, it could have been a possibility for us to go from center to end point with the distance formula to find the radius, and that would be fine as well. Okay, so you kind of have some options. All right, let's talk about vectors for a moment.
It has magnitude and direction.
Okay, so it's really fun because we're doing vectors in pre-calc, and I love when we overlap. Like I'm doing vectors in pre-calc, I'm doing vectors in BC. So like my brain's on like the
Oh, I'm
same.
doing vectors in the 3 classes that are right next to each other.
What?
I'm doing vectors in physics, calc, and astronomy.
Oh, really? In physics too? Right now you're doing vectors?
We're talking about light vectors and stuff. So yeah, light vectors, and then in astronomy, it's also light vectors.
Okay. Do you remember how we talked about the vectors I and J?
Just shoot my little.
Okay, so now that we're in 3 dimensions, we're going to have a third vector K. All right, so now in 3 dimensions, the vector I is 1, 0, 0. Vector J is 0, 1, 0. And vector K is 0, 0, 1. Remember, these are the standard unit vectors.
Can we replace binary with I, J, and K?
Why is that K? K doesn't have a dot in it.
Oh yeah, let's just choose another letter that has a dot in it.
I don't think there are
Just
any
add a
other
dot.
letters with a
Okay.
dot.
Oh,
in
it's
it.
just a dot with a
Oh,
big
with a
circle.
dot over. No.
Okay, now you can kind
You
of
think
tell
these
I'm
guys
trying to
do
make
that,
these
so-
bolded. Remember, vectors are named with bolded letters, so I'm trying to make these bolded. In college, we put like little hats over them. Like we wrote I, J.
You say B.
Okay, with a little
God,
dot.
see, it doesn't work. No.
Do you want to do that? You can do that if you'd like.
It's evil. It's like a mountain.
So we could have a vector with components 2, -1, 5, which we would, that's supposed to be an equal sign, which we could then write as 2i minus 1j plus 5k. Okay, I want you to be aware of the different forms. I know we worked with them, what, in December? Is that when we did vectors?
Some time ago.
Yeah, I think it was December.
I don't know if that's
Okay. And I'll remind you, okay, vectors are a directed line segment with magnitude and direction. Okay.
Direct.
Yep. So if we want to find said magnitude, if we have a vector v with our 3 components,
I'm guessing it's just the distance formula.
okay, so this was our magnitude in 2 dimensions. So now, yes, in 3 dimensions, we're just going to tack that 3rd dimension on.
I like how even when there's a third one, it's still just a square.
Okay, so there are some things that you'll have in your homework that we're not talking about. Like, I'm not going to go through an example of how to find the magnitude of a vector. You've done that. Okay, I'm not going to go through plotting vectors. You've done that. Do your best in 3 space. It's not the end of the world if it doesn't look beautiful. Okay, but there's 2 things I want to talk about. Yeah, 2 things I want to talk about in relation to vectors being parallel. So let's first talk about how we know if vectors are parallel or not. Okay. So describe to me if 2 vectors are parallel, what do they have in common?
They have the same direction.
The same direction always?
The same or opposite?
The same or opposite direction. So let's talk about how to get vectors to have the same or opposite direction. Like if I have the vector 1, 1, 1, give me a vector with the same direction. Say it louder.
5, 5, 5.
5, 5, 5. Give me another one.
-1,
Negative
-1,
five.
-1, -1.
-1, -1, -1. Okay.
Side by side.
Well played.
Oh, it's 0, 0, 0.
Ooh, that's a spicy
No,
vector.
not the 0 vectors. So 2 vectors are going to be considered parallel if vector u can be written as a scalar multiple of vector v.
Zoom in right there.
You put is instead of
2 vectors are
those 2 vectors are
I did that yesterday. I was trying to write something and I wrote in instead of is. I'm thinking about what I'm writing next instead of what I'm writing right now. Okay. So if vector u is 3, -4, -1, and vector v is -6, 8, 2, are these 2 vectors parallel? Tell me why, Gabe.
Just kind of said that. Looks like we have to ride
Because if you multiply u by -2, you get v.
Okay, so if we take 2 times the vector u,
-2 times the vector u.
oh, -2 times the vector u, we get the vector v.
Mhm.
So u is parallel to v.
How do you calculate the direction with the three-dimensional name?
Well, tomorrow we'll talk about direction from the x-axis, direction from the y-axis, direction from the z-axis. We have to do it in 3 parts.
Okay.
Okay. Also, how do you calculate three-dimensional slope? You can't. Okay.
You just do it.
So vectors are actually going to help us a lot with some linear concepts. Okay. Like points being collinear. Okay. If I have 2 points in 3-dimensional space, how do we figure out? Or excuse me, 3 points. Two points are always going to be collinear. 3 points in space. How do we determine if they are collinear? Okay, there's really not like a 3-dimensional slope. However, we can use vectors to help us out. Okay, so let's just go ahead. Let's write down these 3 coordinates and we'll strategize.
Well, you can technically just have a slope with respect to xy, a slope with respect to xz, and a slope with respect to zy.
That sounds fun.
Okay, or we can use vectors, which essentially,
Does the same thing.
yes. Okay.
PQ.
The components of our vectors are going to essentially give us.
Is the third one supposed to be r?
So get it together today.
It's too soon.
Yeah.
Make it S.
PQ.
This is the guy that just complained about K 5 minutes ago.
S doesn't have a dot either.
S, but S looks like 5. It's irritating to work with.
Okay. Simple fix to that, Gabe. Fives have lines.
Oh, let me see. When we're like this.
Put a line through your S.
Pride yourself on your neat handwriting.
I don't
Okay.
Said line in the middle of.
So if we have 3 coordinates, then what we can do is we can create any combination of 2 to make a vector. And we can create, all we need is 2 vectors. Okay? If we create 2 vectors, and those 2 vectors share a point in common, then if they are parallel, they would form a line. If they're parallel, they're going in the same or opposite direction. So if these 2 vectors are parallel, those 3 points form a line. Or if we take, like if you make this vector and this vector right there, if those 2 share a point and they're parallel, we're going to form a line. Okay? Do you see what I mean by that? So it doesn't even matter which one of these you pick to make a vector, but we need them to be parallel. Okay? So which vector would you like to make first?
Q.
Q is a point. Try again. How about PQ?
Oh, I thought they were vectors for a second.
Okay. How do we know they're not vectors?
Because they don't have greater
They don't have the
than-
chevrons. Yes.
Chevron.
So our vector PQ, terminal minus initial, terminal minus initial, terminal minus initial. Okay? Yell out another vector we can find. QR is the first one I heard. QR, if we do QR terminal minus initial to be 2, terminal minus initial for 6, and terminal minus initial for -6.
Ooh, they're parallel.
Okay, so
And they share the point of Q.
since PQ is parallel to QR and they share point Q, then P, Q, and R are collinear.
And P.
Yes, you're actually gonna have to like write and explain that to me.
and
Okay.
and
It needs to be evident to me that you understand what you found and why, and what it tells you.
And the vector from P to R would just be PQ plus QR.
That is true. Okay. Just make sure you find two vectors involving all three coordinates. Don't find PQ and QP because that's not okay.
Big brain PQ.
All right. So your homework assignment is on your gold sheet. This is really all I wanted to talk about today.
What I'll be doing on the bench this evening.
Also, tomorrow is block scheduling day, isn't it?
Yeah.
Okay. So we get to do both dot product and cross product tomorrow. So what will probably happen is we'll do dot product. I'll give you some time to work. Maybe we'll take a little stretch break, and then we'll work on cross product. And then I'll see. I may have a review that I can give you. I can't remember. If you want something, I can't promise you, but I feel like in the past I had a class that pressured me to do one.
What's up with Zimbabwe? I do.
Zimbabwe has a bunch of goody goodies in it, and
Oh, you mean like